Hello. I'm audible or not? I'm audible or not? Hello. Everything is fine. Or let me check it. Hello. Everything is fine. Or let me check it. I think everything is fine. Everything is fine. Okay. So I'm going to teach you a topic which is our orthogonal matrix, unitary matrix, and sub-matrices. Okay. So I'm so first of all of you, myself Divyansu, so to teach you orthogonal matrix and something unitary matrix and some matrices are okay. So everything is fine. So I'm so first of all of you. The definition of orthogonal matrices are a square matrix A is said to be orthogonal matrix. Now the I am teach you previous class. Previous we had definition of orthogonal matrix and related to Hermitian matrices and there are a lot of problems related to Hermitian matrices and skew Hermitian matrices. So okay. So here is a problem related to Hermitian matrices. I'm going to write the problem. Okay, wait for a 2 minute. Let me write it. Problem related to which matrices? Hermitian matrices. Okay. And problem is nothing but it is a write down the set of all Hermitian matrices. Hermitian matrices of order 3 over filled F over filled C. Okay. So how you write the solution for this problem? The problem related to order 3 over filled C. So you may be write as like this. Take some like complex type. So we write a standard form. Here z which is equal to write in the form of x plus iota y. So take a matrices. They have some entries like zi belongs to complex number for all. Here I an imaginary part of zi which is equal to 0 for all I equal to iota equal to 1 to 3 type entries like okay. So here is the S which is equal to the entries are Z1, Z4, Z5 type and Z4 bar Z2 because the entries here are the diagonal entries type entries for the S bar matrices and take Hermitian matrices. So Hermitian matrices is nothing but in previous classes or square matrix A is called Hermitian matrix if its transpose is conjugate is equal to itself. So that is the Hermitian matrices. So here we input all the complex part which is Z1, Z4, Z5 and Z4 bar, Z2 and Z6 type. And one another matrices, one another entries are like this. Entry like Z5 bar, Z6 bar. Okay. Now close this part. And the other condition are same as it is. Okay. So these are the representation of Hermitian matrix complex field. Okay. For the order 3 cross 3 type. Okay. Now come to the next problem, which is also related to Hermitian matrices. And the problem is like this. Here we write a problem. Write down the set of all Hermitian matrices. Matrices of order 3 over filled R. Okay, over filled R. And the solution is the set of all Hermitian matrices of order 3 over filled R. Okay. So here is the solution for this. Take one more entries like this. A L1 plus iota M1. Okay. And L2 plus iota M2. And one another entries take ABC as a diagonal. And here is the element put like this. Here is one more because these are the Hermitian matrices and we take here is the Z bar. So L1 minus iota M1 type entry, and next one is minus iota M2 type entries, and here is L3 minus iota MT type entries, and the all possible value A, B, C, okay, and L1 comma L2 comma L3 are L3 comma M1 comma M2 comma M3 belongs to R. So these are the basic solution for the above problem. Okay, now come to the next problem, which is this is also a representation of when you use a field as a R. Okay, and order is our 3 cross 3 type matrices, and we use here the square matrices because all the wait a minute, it is not all the entries for this is a square matrices like, and here is Hermitian matrices which is equal to a theta equal to a, it means transpose equal to itself, so it means Hermitian matrices. Now come to the next problem, which is also related to Hermitian type problem. So come to one more problem related to this, and problem for this like this. Find the number of non-trivial non-trivial entries in the set of all Hermitian matrices Hermitian matrices of order over filled R. Okay, and the solution part is for this. The number of non-trivial entries in the set of all Hermitian matrices of order n over filled R is, here is the sum entries for here is the entry like non-trivial entry type, and used for set of all Hermitian matrices of order n over filled R. So take S which is equal to, here is entries like this, A1 L12 plus iota MO12 dot L1n plus iota M1n, and another part for taking here as a Z bar. Then we use here the entries for this, which is L1 iota M1, and take diagonal here is B, and L3, here is something element for this which is L2, and 1 2, take diagonal here is A2, and here is last part which is our L 2n, okay, plus iota M2n type, okay, and now take it as a n times, okay. So again we write like this, Ln 1n minus iota 1n, and here is L21 minus iota M2, and here is an type, okay, and take here is the element like this, E iota comma L iota j comma M iota j belongs to R. So these are the entries for taking a non-trivial entries here for all my Hermitian matrices of order n over field R. So these are the basic representation for taking a non-trivial interest type and set of overall Hermitian matrix order n over R. Okay. Now come to the next point. Here is the non-trivial part is like for all diagonal entries which is n. Okay, and non-trivial entries for a straight upper triangular matrices here which is 2 n minus 1 n minus 2 n minus, right, and therefore the non-trivial entries for this which is n plus n minus 1 equal to n squared. So now come to the next point which is I'm saying for this. So here is non-trivial entries for this uh, diagonal entries which is equal to n. Okay, and non-trivial entries in strict upper triangular matrices which is equal to 2 in bracket n minus 1 plus n minus 2 plus dot plus 2 plus 1. Okay, and their entries are n plus 1 and n minus 1 type. The whole entries which is equal to n minus 1 type. Okay, therefore number of non-trivial entries which is equal to uh, here is n minus 1 which is also equal to n square type. Okay, so these are the basic representation for taking one skew Hermitian matrices and okay, so these are the basic representation for this. Now come to the next topic which is our skew Hermitian matrices and some related problem related to this topic. Now come to the problem which is related to skew Hermitian. Take a one problem for this. It's fine or YouTube or not. Take a one problem for this. It's fine or YouTube or not. Okay, so come to the problem, and problem is related to this. Like this, find the this is homework for you.